here, but we will catch up very rapidly. So we're talking about something called confidence intervals. And these will be some notes, and then we'll go to the sheet. We'll go start working on one of the sheets that you go into. So, confidence intervals. So far, recently, we have been talking about hypothesis testing, which is, we take a sample. So, for example, I want to know how many M&Ms, right, are in one of the packs on average. So what is the average number of M&Ms in a pack? So I, take a sample. I take one pack of M&Ms. I find the average. Maybe I take a sample size of 10 packs of M&Ms, or maybe 20, or maybe 100. Who knows? But I find the average number of M&Ms. Right? So I find the average number. Maybe I find that X bar, this average, I don't know, maybe the average is 8 M&Ms. And X bar, of course, is from our sample. Now, the question is, how many M&Ms are there actually? Like, what is the true average? And so our goal is to find this mu, which is the true average number of M&Ms. So we found, in our sample, there are 8 M&Ms. We want to know what is the actual amount. So what do we know? Well, we know that the actual is probably close to 8. And it's probably something close to 8. The question is, what is it? And here's the key is, we never know exactly what it is. We're not going to sit here and get every single pack of M&Ms that has ever been made and average the number of candies in there. So what we are going to do is create an interval within which we predict that this true number of M&Ms will be in. So we will construct an interval within which we predict the mu, which is the true average number of M&Ms, the mu is. So that's what we're going to talk about, is how do we make these intervals, what do they mean, and how do we go from there. So these intervals are called confidence intervals. So these intervals are called confidence intervals. So what do they mean? How do we find them? That's what we're going to know. Okay. Which of these intervals is more likely to contain the actual number of M&Ms? First one or the second one?
First.
How many people think that the first one is more likely to contain the average number of M&Ms, the true? How many people think the second? How many people are unsure? Those people who said second, why do you think that? That's the right answer. Why is second the right answer, right? Yeah, it's a bigger interval. There are just more numbers in here than here. And every number in here is in here. So certainly, if you had to pick an interval, you would pick this one, right? This is more likely to have the real number in it, because every number here is in here. Questions on that? So maybe we are 60% confident that the mu is in this interval. And I'll explain what we mean by this here in a second. Is in this interval. Here, maybe I'm 80% confident. I'm more confident the number is here than here. Maybe I'm 80% confident that the mu is in this interval. So the first interesting tidbit is the bigger the interval, the more confident we are that the mean lies inside it. So, the question is, how do we make these confidence intervals? Let's start there. So, here's how we make them. So, how to construct the confidence intervals. So, every confidence interval has the sample statistic, so x bar or p hat, and the margin of error. Margin of error we abbreviate ME. So what do we mean by this? Well, if we go back to the M&M example, our x bar was 8. So the confidence interval is 8 plus or minus the margin of error. So we're saying, we think that the average number of M&Ms is probably about 8. That's what we got from the sample. But then we need to create the interval, and to create the interval we need to add and subtract, because remember the interval goes in 2 ways. This so-called margin of error. And now we're going to talk about how do you get this. It's just a calculation, just some arithmetic. Okay. So how do we get this? Question? Karina? Yeah, Karina.
So CI equals 8. Is that plus or equals?
This is plus or minus. So you have to add on one side and subtract on the other side. Good question. Shamira, same one? No. You sure? Okay. So the margin of error, here's the formula. So the margin of error for a t-test, and this is back to the old t-test. So if it says find the confidence interval and we need to use a t-test, remember a t-test is used for a quantitative variable. This is a quantitative. How many M&Ms are in the bag? Quantitative variable. And remember we use t-test because the standard deviation of the population is unknown. And the formula for the margin of error is the this critical value, again, and we talked briefly about that before, and we'll revisit what that means, times the standard deviation over square root of n. This is the critical value, and again, we will discuss how to get that. Critical value. N, as you all know, is the sample size. Sample size. Does anybody remember this S?
No.
Standard deviation. Yep. Dex, go for it.
You said so of the population is unknown.
Standard deviation. Sorry. SD, not SO. I'm sorry. Kendra, question? No? Brian, what's going on? We also have the margin of error for a Z proportion. So remember we were talking about Z proportion. This is what you all just took the exam on. And remember this is used for a categorical variable. And the formula is Z star, that critical value, times square root of P, Q, and N. And what is Q? I'll explain that in 1 second. Critical value. P, as you all remember, is the probability of success. N, of course, is just sample size. And Q, let's bring this down here. Q is just 1 minus P. It's just another way to write 1 minus P. It's a little bit, people are like lazy, right? They don't want to write 3 things when they can just write 1. Q just means 1 minus P. That's it. All of it is under the radical, right? Okay. So, let's talk about how to find these right here. Yeah, next.
Parentheses, where you got to see D star thing.
Yeah.
Parentheses, no.
Here?
Yeah.
Right.
Beside it.
Square root
Square root
P, Q over N, and here's Q. Okay, so let's fill out this in-class problem. There's a table here that talks about T star and Z star. These are called the critical values, and you'll need that along with the stapled tables. Miss Alvarado. Huh? What about them? Yeah, they were right on the desk when you walked in. You didn't pick them up? Then you should ask one. Hey, are the papers still over there? Huh? Okay, so why don't you grab 4 copies? 4 sheets. Okay. So when we ask you to find a confidence interval, we're going to say find a 90% confidence interval, 95%, 98%, and so on. So this is called right here, and this is not to turn in. Please notice I'm taking the feedback. This right here is called the confidence level. So the confidence level. So either I'm like 90% confident, 95%, and we will tell you that in the problem. 98%, 99%, and so on. Okay. Now, let's take a look. If I'm talking about means, am I using T or Z? Means. T. Z was the proportion, so maybe I'll write Z over here. Z are the proportions, and these are T's. Okay, so here's what you do. Pick up the table, flip with me please to where it says T distribution. So this will be page 6, it says on the bottom of the table. t-distributions. So they told us for the first set, n equals 10. If n equals 10, does anybody remember the degrees of freedom? How do we get that? Tikertro? Say it again.
1 minus n.
If I did 1 minus n, I would get negative 9. So I don't want negative 9. N minus 1. N minus 1. So over here, for this column, the degrees of freedom equals 9. So all you do to get the t star is you come over here. Let's look at 9. Here's 9. And which confidence interval? This is 90%. Let's go to the bottom. Here's 90%. Number 9, I get 1.833. Do you guys agree? 9 degrees of freedom, 90% confidence interval, 1.833. Questions? That's the answer. Okay, let's do the next one. 95%, 9 degrees, 2.262. Okay, let's fill out the rest of the means. Please notice that the second column, n is 30. So the degrees of freedom, well, you guys can figure that out. So take about a minute and a half, fill out columns 1 and 2. And if you have a question, please ask me. Sergio, okay. Let me come there. Okay. 9. No, because he said 90%. Okay, you good? You got it, Alex? You're good. Okay, please verify that you get what I have up here. If you're not getting this, please ask. This is going to be something that we'll need to do all the time. You don't need to memorize this because the table is given to you. Just understand how to use the table. Let's take another 30 seconds, then I'll explain this last column here. Yep, so I looked over here and it said n was 10, and the degrees of freedom are always n minus 1. So that's how we get the 9. Okay, so I'm over here on where it says t distribution. And so I come over here to df, I go to 9. And then it says 90% level, right? The first one on the chart. Like on the handout right here. 90%. So I come down here to 90%. And I just kind of see where it matches up, and it matches up at 1.833. Does that make sense? Okay. Other questions on that? Okay. The Z is a little bit more interesting because the College Board gives you the Z table, except it's not listed down here what those confidence intervals are. So we have to do a little bit of work on our own. So let me explain how to do this. So for the Z, if you think about a confidence interval, so if we want a 90% confidence interval, what that means is the following. Here's our curve that in between here and here, so in between our interval, how much of the data do you all think should be here if we want a 90% confidence interval? Okay, very good. It's not rocket science. So this is 90%. Then how much is on each tail? Like how much is here and here? This is 0.05. This is 0.05. Now, unfortunately, this table is not presented that nicely. the way the table is presented is, they give you the value right here, and they calculate all of this area back here. So when we want a 90% confidence interval, we want to get this number right here. We want this number right here. So how much area is actually back here behind it? Not 90%, but 95%. Please note, we would like to find this value right here. This is our Z star. So to get the Z star, if we want a 90% confidence interval, we want to say, what is that Z value where to the left of it, there is 95% of the data. Here's 90 between here and here, and then you add this 5%. So we want to know, where are we 95% to the left of this point? Alex?
So if you originally wanted 95%, you would have to put 100.
No, not 100. Let's take a look. Let's take a look. If I wanted 95, so I come here. So from here to here is the 95, right, Alex?
Mm-hmm.
Then we have two tails. So how much is here and how much is here? In total, there's 5% on both tails. So each tail has, wouldn't this be 0.025 on each tail, Alex? So how much do I want? I would like all of this area. How much is that? 95 plus 0.025, 97.5. No? I can do it again.
Why did it switch from 0.05 to 0.025?
Because, okay, so this one was asking for the 95% confidence level. This one was 90%. So here, there was 90. You sure?
Yeah.
Okay, so let's walk through how to do this. So for this first one, we want to find this point right here where there is 95% of the data on the left. How do we do that? We go to the Z table right here and look inside the table for 0.95. It's not on this page. You got to turn the page. Where's 0.95? Right about here. Where I circled it here, 0.9505.
Yeah.
That's the number that is closest to 0.95. I would recommend going above rather than below. So 0.95, what is the Z value? 1.6 plus 0.05, so it's 1.65. Okay, let me do another one. 95%. We just showed how we would like, we don't want the 95, we want the 95 plus 0.025, so we want 0.975. So let's go over here. Where are we getting 0.975? Right here, which I'm circling in light blue. 1.96. 1.96. Okay, so let's look at the 98%. So if I want 98%, let's draw the picture. .98, 0.01, 0.01. So we want to look for the number that is over here. So how much is it? 0.98 plus 0.01 is 0.99. 0.99 is right here, 2.33. And finally, 99%. 99%. Here's 99%, 0.99. How much is this? What is it? 0.005 over here now. 0.005 here. And 0.005 here. And we want all of, bless you, this area. So what do we want? 0.995. Eddie Paul question? Yep. Guys, too much talking. 2.58. Say that one more time, Eddie.
Oh, on the last one, why is it 2.3?
3 instead of what? Okay, because because you want to go a little bit above, not below. So you want to go to this 0.9901. Do you see that? And that's a 2.33, Eddie. You good? These are the ones we have to have. Again, you don't have to have this memorized, but these will be the ones you're going to use on your homework sheet. For this whole unit, these are what you're going to want to use. Karina.
For the 95%, it's 0.975 on the front.
Mm-hmm.
You said to go a little bit above.
A little bit above, yeah.
You want to exact 0.975.
Yeah, okay, sorry. If there is an exact point, I'll go to the exact. If there isn't an exact one, then go a little bit above. Good question. Good question. Okay, let's take a look. All right. So, all right. We now have an interesting question on the back. So now let's look at how do we actually build these confidence intervals. That's where we're going. So let's look at number 1. Okay. The Mars company reports that 20% of its M&Ms are brown. Okay, right away you have to ask yourself, is this, and do not say it out loud, please ask yourself, and I'm totally hopeful we get this, is this a categorical variable or quantitative? Do not say it out loud. Please think to yourself. And then you want to think, should I use T star or Z star? Think about, are we doing a categorical or are we doing quantitative? So are we talking about means if we're doing quantitative, or are we talking about proportions if we're doing categorical? And then should we use Z or T? Here are the answers I hope you came up with. These are the 3 answers we hope you got. All right. Are there any questions on how I got this? If so, please ask me. Okay. So the Mars company... Yeah, Dex?
How do you get it?
Okay, so I knew it was categorical because these are talking about colors, and colors are a category, right? They're not like numbers. It's not like 1, 2, 3, 4,
Oh, yeah.
5. And then anytime we have categorical, we use Z proportion test, and anytime we use Z, we use a Z star instead of T. So basically, if you get this, these are...
No. Okay, no, I'll talk about it.
Okay. So the Mars company reports that 20%, so the P hat, right? So 0.2, and assume that's what we get from the sample. And they're asking us what sample size would we need to have a margin of error equal to 0.01, okay? Well, we just said margin of error equals Z star, yes ma'am, times square root of P Q over N. Okay? What is the margin of error in this case? Right, they want this to be 0.01. Okay, let's look back at the front and find the Z star. So please notice they want a 95% confidence interval. The Z star should be 1.96. If you look back at the front side of the sheet, this is 1.96. The P is 0.2. The Q is 0.8. And we need to get N. That's what they're asking us. So let's solve this out a little bit. So this is the same as 0.01 equals 1.96 times square root of 0.2 times 0.8 is 0.16 divided by N. So I want to solve for N, so I need to divide both sides by 1.96. You're probably going to want your calculator here. So you get some number, 0.00510, and that equals square root of 0.16 over n. What do I do next? Folks, what do I do next to solve for n? Square both sides, good. I get a very small number, 2.60308 times 10 to the negative fifth.
That's a big number, sir.
Negative fifth, so super small.
Super small.
Okay.
That's the problem. That's super small.
Yep, go ahead, Alex.
So point with 4 zeros, right? That's the negative.
Here?
five? No.
Here.
Yeah, that's what it means, right?
Yeah, so it's like 1 and then 4 more. Yeah, so 4 zeros. Multiply both sides by n, and then divide by this. They love questions. There'll be like one multiple choice question like this, folks. I mean, you can just already predict it. So it's 2.60308 times 10 to the negative fifth times n equals 0.16. Just multiply both sides by n. And now we just divide by 2.6. Questions? Alex.
So, I'm pretty sure I did what you did.
Okay.
That's what I got. 6153.
Really? Oh, okay. So probably the difference is, like, I didn't round. I just stored this in the calculator. So that's probably the difference. But if you just like write like how you did it, then you would have been fine too. We're gonna follow the work. Are there questions on how to do this? Okay. All right. So let's look at number 2. Presidential Pete is on the home stretch of his campaign and wants to know if the polls predict that he will win the election. A recent poll of 1,020 randomly selected voters found 484 responding in favor of Pete. He wants to take another poll, but he only has enough money to pull 500 voters. So N initially was 1020. And the new N is 500. We want to say N1 and N2.
You skipped the whole.
What's going on, Dex?
Well, like 484. What was that?
So we just said, so all it's asking us is how will this change affect the interval? There's nothing about the 484.
What?
So, if you look at it, think about this. This is again another z-test, so the margin for error is given by this. So let's look. If n is smaller, then what happens? Well, if n is smaller, this denominator is smaller, which means this fraction is bigger, which means the square root of a bigger number is bigger than it was before, which means the margin for error goes up or down. If n goes down, the fraction gets bigger, so this multiplied by a bigger number must be bigger than it was before. So if n is smaller, the margin of error increases, meaning the interval, and remember the interval was just p hat plus or minus the margin for error. So if the margin of error gets bigger, the interval must also get bigger. Or gets wider if you want. So if this number goes up, that means I'm adding something more to p hat. which means that's going to be a bigger number. Now I'm subtracting something more, which means we're going to have a smaller number. The interval widens. The interval widens. Alex. And if n gets bigger, the interval will get smaller or get narrower. Yep. Absolutely. So let's push the thinking a little bit. Let's push the thinking here. So this was the chart we had already filled out. So if the confidence level goes up, does the margin of error get bigger or smaller? If the confidence level goes up, think about this. Remember, margin for error is z-stat times square root of PQ over N. So if the confidence level goes up, what happens to the margin of error? The margin of error get bigger or smaller? Think, folks. It has to be bigger. It has to be bigger. If this number is getting bigger, which it is, then this margin for error must be getting bigger. The margin for error goes up as the confidence level goes up. And by the way, we talked about that earlier when we said that the wider the interval, the higher the confidence. So if the confidence level increases, then the margin for error increases and the interval widens. And of course, the opposites are also true. Shamar. So the interval is like between 6 and 10. That's the interval, and the level is like 95% confidence level. Does the difference make sense? All right, let's go to the next problem. So part B. If Pete wants to decrease, actually let me skip B. I want to go to number 1. So let me skip B. Don't worry about B. Let's look at number 1, and this is kind of where we want to end today, is doing problem number 1. So on problem 1 it says, in 1882, and at the end of this problem I'll explain how to interpret a confidence interval, which is like the key piece also. So in 1882, Michelson conducted a study to estimate the true mean speed of light. 30 true trials were conducted to find a mean of blah, 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 and standard deviation of this. Find a 90% confidence interval, interpret your interval. When it asks find a confidence interval, we have again the 4-step process. And let's walk through it. It's a little bit abridged version, so a little bit shorter, but again, we need to walk through it. So step 1 is always name and except this time it's not a test, it's an interval. Name the interval. And this is a 1 sample, because they only took the 32. Yeah, Shamar?
What is this called again? The test for what?
These are the steps to find a confidence interval. So it's a 1 sample mean t interval. Anytime you're talking about means, we're using t's. And again, just like always, you want to kind of like annotate. So it's 1 sample because they only took 1 group. It's mean because we have a quantitative, and this should look very familiar, folks. And t because, let me write this down here. The t is because the standard deviation of the population is unknown. and then we define our variable. So the variable we care about is this mu. And mu, what do they tell us in the problem? So what are we looking for? We're looking for the true mean speed of light. Tell them what you're solving for. You're solving for the true mean speed of light. All right. That was step 1. Step 2 are the conditions. Again, this is all listed on the board already over there. The conditions are, the first one is random. And do they tell us it's a random sample? No, they don't, but we're going to assume, we assume that the 32 samples are random. The next one, we have random, we have independent. So independent, we're going to assume that one sample speed does not affect the other. One sample's speed does not affect the other. And the third one is normal sample. And the reason we know this is normal, does anybody know why? Ah, very good. Central limit theorem. And why does that apply here?
It's larger than 30.
Excellent. Very good, very good, very good, very good, very good. Number 3. So n is greater than 30, right? 32, if you want to put in parentheses, is bigger than 30. Therefore, according to the central limit theorem, and if you want to abbreviate CLT, it's okay. According to the central limit theorem, the sample distribution is approximately normal. All right, those are our 3 conditions. And now the next step is the math. So the math, we always start by writing the formula. So we're going to say that the confidence interval, Ci, and the confidence interval is x bar plus or minus, and now you got to put the margin of error. And again, it's x bar because this is a t-test. Sorry, a t-interval to be specific. X bar plus or minus, and the formula was t star times s over square root of n. Dex?
Is that algebra?
Yeah, there is going to be some algebra here.
Does it mean you be doing on the calculator?
Yes, you can do it on the calculator.
I can?
Yes. Okay?
Can it be done on?
It will take a long time to do it by hand. So, let's plug in what we know. X bar, they gave that to us. What did they say? X bar was 756.22. Plus or minus. Let's find the t-stat now. You got to go and find this. So look at your table. What kind of confidence interval? They want 90%, so I'm going to go to T. My degrees of freedom are 31. Unfortunately, 31's not here, so I'll just go to 30. And they want 90%, so it's 1.697. Do you all agree? Please verify. Don't just say, yes, I agree. 1.697. All right, 1.697. The S, standard deviation they gave me, 107.12 divided by square root of 32. Okay, this is where we go to the calculator. Can I borrow an Inspire? And then an 8384. I need an 84 also.
Mine's like dying.
It's gonna die. You start not
Yep.
It's gonna make it. Yeah, I'll be alright. Okay, so on the Inspire, here's what you do, book. Sorry. Okay, so how do we find the confidence interval? So on the 83, 84, and again, tomorrow we'll have a copy of the steps for you. So turn the calculator on. And again, if you have 83, 84, you go to stat. Again, please write this down if you have 83, 84. You scroll over to tests. and then scroll down to T interval, number 8. T interval is number 8. Click enter. And then the X bar is 756.22. The standard deviation is 107.12. The N is 32, and the confidence level is 0.90. And click calculate. And you have one number, comma, another number. You can't see it here, but you'll have one number, comma, another number. That is your confidence interval. So again, on the A384 stat, tests, and it's a 1 sample T interval, and then punch in the data that you have. On the Inspire, please write the steps down. You're at the calculate screen, you go menu, statistics,
What number?
6, just, stat tests, which is number
7.
7. Is it not stat? No, it's not stat test, sorry. Oh, sorry. Confidence intervals, obviously number 6, what am I saying? And you want a T interval, number 2. And are we putting in data or stats? This time it's stats. So you're gonna go to stats here and click OK. The X bar, put it in, 756.22. The standard deviation, 107.12. The N is 32. The confidence level is 0.9. And before I click OK, just verify again what's going here. The X bar, we got this. Standard deviation, N, and then the C level. Click OK. And then it gives you the lower bound and the upper bound. So the lower bound is 724, put it in parentheses, 724.113. The upper bound, guys, why is there talking in the back? 788.327. And there is your confidence interval. CI equals. With parentheses always. So there's the math. Draw the picture. Draw the picture. Yep. 90% because it tells us to do a 90% confidence interval. Okay, so our confidence interval is from here. Call this 724.113 over here. 788.327. Shade this area in. You could write over here CL, the confidence level is 90%. And then one last piece is the conclusion. That's all we got to write is the conclusion. And the conclusion is the interpretation. So here is the conclusion. And it's always the exact same sentence, just like for the p-value, blah, blah, the rejection. It's always this exact sentence.
Okay.
So here's the sentence. So conclusion, and again, I'm very optimistic that Magali will make a poster for this. Again, not to put anybody on the spot.
Never made one.
So here's the sentence. We are this, guys. We are, the blank is you put in the, I'm going to write below it where you put in the confidence level. So in this case, we are 90% confident. We are 90% confident that, and in this case, you want to put this blank. This is the population parameter. So this is what you defined. So in this case, we defined it that the true mean speed of light, is between lower bound, which in our case was 724.113, and upper bound, 728.327. The only things that will change are what is underlined.
88. That's it.
Huh?
88.
Oh, sorry, 88. And this makes no, yeah. Thank you. And there it is, folks. So the only things that will ever change are the underlined parts. Now, what does this really mean? All this says is that we are 90% sure that the true value is somewhere between this and this. That's what we're saying. The true value, we are 90% sure it's between this and this. So there's a 10% chance it is not there. But we're 90% sure it's between this and this. That's what we mean by a confidence interval. Okay, finishing up with the last part. Here says, all right. Extension question. How could we decrease the size of the interval? Well, you can decrease intervals by two ways, as I just discussed. You can decrease the interval by doing what? Well, you can decrease sample size. No. Maybe I should say increase sample size.
Yeah.
Increase sample size. Or make the confidence level less. So instead of going for 90%, just say I'll go for an 80% level. Make the confidence level smaller. Make the confidence level smaller. And why would they want to do this? Because if the interval is smaller, then it's easier to check where the true mean is. If I have a really small interval, right, it is easier to determine what the true mean is. In other words, I'm more precise or more accurate. What is the risk? Either I'm less confident or it's going to cost me a lot more money to increase the sample size. Those are the trade-offs. Okay, so a lot of information for tomorrow. So here's what we're going to do tomorrow. Tomorrow I'm going to go through 2 and 3. So what do you all have due tomorrow? Tomorrow you have the Common Assessment Review due. Then Thursday, although we don't have class, the first problem set is